sector. And the first one will be the company Cubert, who is going to talk to us through René Heine. Is going to talk to us about and the new applications. Thank you very much, René, for being with us today. Thank you for taking the stage, the floor, and the attention of all the participants of this fantastic webinar.
Okay, thank you very much. I have the impression you handed over the word to me. So indeed, we are also seeing a big push of on the technological side of the hyperspectral imaging community, and we as Cubert always wanted to be on the bleeding edge of this technological front. So my name is René Heine. I'm CEO here at Cubert, and I'm also founder or co-founder of Cubert. And Cubert is all about new advances in hyperspectral imaging. So we started this company nearly 10 years ago in South Germany, and we are concerned about snapshot hyperspectral imaging. This is what we do since we started the company. And what are the impacts of hyperspectral imaging, of snapshot hyperspectral imaging? To understand that, it is important to understand what does snapshot technology mean. There are plenty of ways to generate a hyperspectral cube. Very commonly in use at the moment are two techniques. The one is you apply a filter wheel. This is shown on the left in this image, and scan through different channels and subsequently add all these single images together to generate a cube. It's pretty interesting technology, and nowadays with fast switching filters, it can even be done in less than a minute to generate a cube. The most frequently used technology for sure is push-broom spectrometry, where you just generate a line of spectra, so like a scanner. And to generate a cube, you have to scan this single line and then add all the single lines together. For conveyor belt applications, that's pretty convenient. However, there are a lot of applications where you simply don't have the time. So we are concerned about snapshot spectral imaging that's shown completely on the right. So we generate a full hyperspectral cube in an instance of a second. So this is very, very different to all the other technologies, even if they are very fast. Sometimes they can be fast as a few seconds, but we can be even faster. So, and this technology gives you some advantages. The first is it's pretty flexible in the optical side. So it's possible to attach this technology to any other optical thing which is out there, because it's working like a normal industrial camera. So here, for example, it's attached to a microscope, and you can get spectral responses in a microscope without any problem. So this is as any other CMOS camera, you just screw through the microscope and that's it. The other thing, it can be very, very fast. For example, you can measure plasma effects. So here you see a setup where we generate a plasma of two welding wires, and we can measure in a few microseconds a full hyperspectral cube. So on top you see the image, and on the bottom you see some sample spectra which you put out of the image. But in every point in these images you have a spectral response, and that gives you the opportunity to measure the parts which are in the plasma. Is it liquid metal, or is it gas, or is it oxygen, or which kinds of metal are in this plasma? And the next one is a very prominent application where you use snapshot hyperspectral imaging is for robotic applications. So as soon as a lot of movement, snapshot hyperspectral imaging can be used as a normal DSLR. So you can use the whole processing chain, which is already there to work on DSLR data, meaning, for example, here you see a stitching algorithm which generated a hyperspectral map of an area, and here you see the calculation of the plant health. And these snapshot technology makes the work very easy. Today I want to talk a little bit about the innovation in that field, and we have in cooperation with Delta and EOF generated a new kind of hyperspectral imager, which we call the ULTRIS. The first ever light field based hyperspectral imager out there. And it's our new camera model. That means it's based on light field. So there's a possibility to generate a 60 data set, X, Y, lambda, distance, angle, and time. At the moment, I have to tell you that we are 100% concentrating on X, Y, and lambda, because I think that's the core of every measurement. However, all the other data is already there and will come to its use at a given time. So we can generate already hyperspectral videos, and these videos will be recorded with 400 pixels, which gives you the immense amount of 160,000 spectra per second, which is in my mind remarkable. And each of these spectra will implement 100 channels. And thus it's, in our opinion, the fastest system on the market. It gives you 400 lines per readout. So in a milliseconds, you generate 400 lines. And when you do subsequent measurements, then you can generate up to 2,400 lines per second. And even the performance at the moment is pretty outstanding. So on a normal sub-notebook, like a Dell XPS or whatever, you can generate 800 lines per second. So not an industrial PC, whatever, a really small computer device, and you can do that on robotic applications as well. And the big question is, how do we do it, or what is the core of that? And in my opinion, the core of this innovation is that we are able now to use really huge sensors to its full purpose. So the ULTRIS is the first sensor in the market, the first hyperspectral camera, which uses a 20 megapixel UHD sensor. And if you compare that to conventional push broom devices, which are basically bound to 1 megapixel sensors roundabout, then the amount of data you can get per readout is 20 times higher already. And I have to apologize a little bit. We are still in the process of IP protection. So I don't want to talk too much about the technology. I'm very happy about questions. So if you're interested in the technology and in its usefulness, please get in contact with us and we can talk with you offsite the presentation. Today I want to talk about the performance of this device. And to do that, we did a small test setup. We compare three techniques which are on the market at the moment: a Firefly, a Butterfly, and an ULTRIS camera, and side by side on the same setup. And if you look at the results, then you can see that this older Firefly camera has a 50 by 50 hyperspectral pixel resolution, which makes the image look a little bit blurry. However, the spectral quality is very good, and you can calculate applications like NDVI or Red Edge pretty nicely. However, with a much higher resolved Butterfly technology, which is based on a filter on chip sensor design. We see a higher resolution. However, we had a lot of problems with the image noise. And this is remarkable of the Ultras at the moment. So we have the Ultras Q20, which has this 400 by 400 pixel, and we don't see a lot of noise in these images, which is the most striking point for us as a spectral imaging company. And please have a look at the spectral response curves, which we put out here. So we plotted basically for every system 3 points in each image, which correspond to each other. And we also put out the standard deviation. So the bars are the standard deviation, and as you might see, the Firefly device has roughly 1% standard deviation, whereas the filter-on-chip based Butterfly device had a much higher standard deviation in this comparison. And with the Ultras device, we can gain again roughly 1% standard deviation, which makes it unique. Furthermore, we could eliminate one of the issues we had with all our other devices so far. So the here you see these spectral channel response curves, and I've plotted every 7th or so channel, and you see they're equally spaced. So we have equally spaced channels which are nicely aligned beside each other, and the full width half maximum of each channel is roughly 2% of the center wavelengths. So it's pretty nice device. You can acquire this camera at the moment in different for different applications. So we have a standard camera which you can put on a drone, which has 350 grams. We have a more industrial graded housing, which is IP65. And we are also bringing this technology underwater because there's a lot of research at the moment going on in underwater environments. We don't stop at giving you the hyperspectral data sets. We are usually also capable of bringing you to your application. So in the end, every spectrometer in the world needs to find an application where it's useful. And to apply a spectral data set in an application, you typically have to distinguish between materials or more general find solutions to a problem. And to do that, we typically use quantification, classification, or qualification. And to get to a solution, we usually need a software application which does that. I wanted to show that live today. However, we had some technical difficulties together with the EPIC team. So thanks for the support, but I just put in some slides. So behind is the setup. Next time we show it live. What I wanted to show you is how to classify an image. So I just shortly before this recorded an image, and you can see a set of different fruits here, pretty standard the technology. So we use the Hyperspectral mirror, and all you have to do to generate your application is you draw some lines to teach the classifier which object is in which location. And after that, you can train the classifier, and it will now understand to classify between these different fruits. You can even segment these fruits. And the cool thing is, that is what I really love to show you, but cannot do today, is now you can export it immediately and the thing starts running on the camera itself. So the training of these kind of data sets take roughly 5 minutes and you have your application on the go. I want to go out on this presentation with another example why this camera is so unique. So here's one image we just took out of a driving car. And this shows somehow the potential of these technologies. So it is not complicated anymore. There's no moving artifacts or anything like that. So as soon as you have a camera like that set up, you can measure nearly everywhere. So I want to thank you for your attention. And I want to refer to our website. So if there's more interest, please have a look. I hope we have some more information on there. And otherwise, please get in contact with me. And I hope I can answer some questions.
Thank you very much for a very nice presentation. Of course, this is a very interactive meeting. I'm going to tell you a secret. When I was a little boy, I wanted to be a radio show host. And this is for me as close as it gets of being a radio show host. So anybody who has a question, you can post it in the chat. We already have some questions there. And the first question comes from Narcis Trinka. Hello, Dr. Narcis. It's from the Institute of Measurement Science from the Slovak Academy of Science. And he's actually comparing the work that they make with yours. And he said, hello, in our work with hyperspectral imaging done outdoors in sunny weather, we have observed that the automatic exposure time of the... And here is the question. What is the solution to obtain non-saturated image without manually changing the exposure time?
Okay. Typically in our software suite, you have the possibility to have an automatic exposure time correction, which also takes care about the referencing for white standard. So typically that should work out of the box. Everybody who's working with spectral images knows as soon you have big deviations in exposure time, that might introduce some errors, and you have to be cautious with that. But for, let's say, moderate deviations like a factor 2 or 3, that should work out of the box already.
We also have some questions about the Ultris camera. I'm going to summarize them all into one. So people are wondering, actually I know many of our members are getting very, very interested on the Ultris camera. So first I would like to congratulate you on this very big achievement. But some people are wondering about the possibility of working with you in the sense of developing filters for such camera, like polarization filters, for instance. Are you looking for partners? Are you looking for potential suppliers on this?
Oh yeah, we're always looking at partners, especially the request about the polarization is very interesting. This technology will also be possible to put polarization as another source of information. And at the moment, we only work with linear polarizing filters, which we can turn, but there are much better solutions out there. Please get in contact with us.
An interesting company from France, Cilios, Vincent Soguet. Hi, I went to visit Cilios last summer. They are an optics manufacturer in France. He's actually wondering what kind of lenses we can adapt to the Ultris 20.
Oh, that's a great question. Thanks for that. Maybe that wasn't explained enough. So at the moment, you don't need any lens. So the camera has the optics included already. However, we are working on attaching different lenses as well, but that will take us some time to give you the opportunity to switch lenses. But please, let's discuss your application and find out what possibilities there are.
Cilios is actually a very interesting company for you to discuss. Vincent, whenever you want to engage further with Epic, you know where I am. I want to ask you myself something that is actually running in my mind. It's about the snapshot imaging. That concept you have been pushing quite heavily in the industry especially in the last 2 years. And I know it has raised some interest by some of the markets, especially the defense, the safety, the security, the medical. But how do you see snapshot imaging in real-time process monitoring when actually lots of images need to be collected and things change in real time?
That's the ultimate goal we have. that's where we see the end of the line for the snapshot technology. The reason is, at the moment, if you look at the industrial imaging market, then you will see that the majority of applications are full frame. And I don't see any reason why in the future not hyperspectral applications are in majority full frame. So you're totally right. There's a problem with the processing times and stuff. But that's the reason why we are working on really lean solutions, which are very fast. And as I said, at the moment, I can already process 2 full images per second on my sub-notebook. So there should not be any problem to put that in a line and do the same as you are used to from the line scanning devices, with the additional opportunity to have much more stable results. Meaning, if you are in a line where things start rolling, or where you want to measure stuff which is in falling situations or stuff like that, then you can much easier use a snapshot device.
There is a company in Europe, in Denmark, but I know them very well in the spectroscopy market. It's called Ipsen Photonics. I think you also know them quite well. My friend Thomas Rasmussen, hi Thomas, is wondering about what is the transferability between different instruments.
Oh yeah, great question as well. So we had issues with that, with filter-on-chip devices. The reason was that the channels are differing between devices. So on one device, you might have a channel here and the other is there, and then the next they shift slightly, and then the transferability is not always given. However, there might be solutions already on side of IMEC. But with the new approach, we can control the position of the channels, and then the transferability is given again. However, to be fully honest, this device is very new to the market, so please let's try it out. Our opinion is it should give easier results on that issue, but we have to find out with a device which we have under half a year of experience in the field.
And what is being very clear in your presentation is that you are looking for partners, and that's something that we really like at EPIC. And also something that we really like at EPIC is that we get questions from completely different companies, and in this case, agencies. Robert Zucker is from the US Environmental Protection Agency. And he's wondering, can your camera measure fluorescence on a microscope?
Yeah, we would shift. If you want to do that immediately, we have solutions for that. So yeah, fluorescence is not a big deal. If you want to measure fluorescence outside, like the fluorescence in chlorophyll, we are still thinking about how to capture that, because there we need a bandwidth of under a nanometer. But if you're talking about fluorescence on a microscope, yeah, we can do that.
Next one is Pierre-Jean Bidet, and he's from Camach.